Hello, everybody, and welcome again to another Kennametal webinar. Steve George and Danny Davis.
How you doing, guys?
We're very happy to be with you again, and we think we've got a really interesting topic to present today in the KenTIP FS portfolio. Again, through these challenging times, we hope everybody's being safe. We're continuing to practice our best safe practices here, and
we have our plexiglass in between us.
Yeah, and we hope that everybody out there is being safe as well. So just before we get started, so we're both here on the Click meeting doing this webinar. We're also live on Facebook, and this will be recorded on Facebook that you can watch later. Definitely we want some interaction. So for those of you that are in the actual webinar, if you look down in the right hand corner, there's a place that you can enter some questions. We'll see those questions and try to get to them as we go along. For those of you on Facebook, please give us a like our Facebook page, check things out. We're going to have more webinars coming. There's already a lot that you can choose from. We just did one recently on SGL drills, Harvey 1TE, Harvey Ultra 8X, a lot of things that you can check out there, and a lot more content will be coming up. So also, feel free to give us just a comment. Did you like the video? Do you have some ideas for us? And where you're from, things like that.
Yeah, just a shout out, anything.
Yeah, it means a lot to us. Yeah. So, but also questions. So for those of you on Facebook, along with that, feel free to leave some questions. We're going to be looking at those questions. We've got a team from our CAST guys checking those out. Also try to answer as many of those live as we can. So. Yeah, thank you very much, and let's get started, Danny.
All right. So today we want to talk about KenTIP FS, Steve. So, I know that's a modular drill, but before we even get started, I think it may be good if we talk about what is a modular drill and how it compares to, say, a solid carbide drill or even an indexable drill.
Okay, great. Yeah, so let's talk about that a little bit. So. We talked about solid carbide drills in the last webinar, and that's pretty straightforward, right? Single piece of carbide. When we talk about something that's modular, usually we mean that it's in a couple components, and those are kind of standardized components that could be assembled. Where we kind of vary from indexable drills is that when we get into indexable drills, we're talking about typically a steel body and inserts that can be indexed or rotated to new cutting edges. So typically we have a certain number of cutting edges that can be continuously used there. With our modular tools, we'll have a solid carbide head, and that's full contact all the way across. Steel body can be assembled.
Well, I think it's a good point. You said full contact all the way across, and when I think about a modular drill, it's kind of like an indexable because it's got a replaceable carbide insert, if you will, but it's full contact all the way across, which means it's there's no break in the carbide on the drill point. Okay, where an indexable drill will have, as you already stated, inserts that you can replace and not actually index, which you can't index this one on a modular drill, but you index on an indexable drill. But it's usually not carbide going all the way across, and because of that, it's not always two edges effective. So you may have a two-fluted indexable drill, but when you start calculating your speeds and feeds, or especially your feeds, you need to calculate your feed on the effective cutting edges. So where a modular drill is going to give you two effective cutting edges, just like a typical two-flute drill, where indexable would be a lot of times just one cutting edge.
It's a great point, and definitely something to understand. So when you're, and we'll get into this as you start to look at where the two overlap, what might be a better choice for you. Yeah, so we can kind of go back one slide, Danny, real quick. Let me just finish a point while we've got this slide up. So the way this chart kind of works here is you can look at diameters going down. So when we look top to bottom on this chart, you've got diameters going down, and you've got hole quality going from left to right. Right. So when you look at that kind of upper left corner here, let me just turn the pointer on here for a second. So when you look at that upper left corner, that's where you're talking the smallest diameters and a tighter hole tolerance. So that's where we're looking at more kind of ITT T8 range. As we start to spread over to bigger holes, and also where we have a little bit more hole tolerance, we find modulars in the middle. So good quality holes,
Right.
But also, little larger diameter tolerance, and then a little bit bigger spread. And then the far end, we get to indexables. We also get into sort of our hybrid combinations like KSEM Plus, where we might have a modular tip with outboard indexable inserts.
Yeah.
So, all right. So kind of with that, we've got a range, and so this slide you kind of get an idea of our range. So we've got the KenTIP FS, which we'll talk about here, and this is now a broader range than what we had before with KenTIP because we're down to 6 millimeter and up to 26. We've got our original KenTIP to choose from, and then we get into KSEM and KSEM Plus. So we're not going to talk too much about KSEM and KSEM Plus today, but they're a solution that's held in by a screw. It's a very strong, very rigid solution. So, that kind of handles the bigger diameters, and also you can see things like interrupted cuts and stuff like that. But what we have here with KenTIP FS is we still have an extremely strong connection, good body life, good tool life, but we can hit those smaller diameters.
So how do KenTIP FS and solid carbide tools compare? I mean, we talked a little bit about it already, but exactly how much do they compare to each other?
Yeah, that's a good question, Danny. So, if we talk about some things that we've got shown here of kind of common perceptions. So solid carbide drills, we're talking about it's the most rigid solution because it's a fully carbide body.
Yeah, we talked about that in our last webinar.
We did, and typically the very high metal removal rates. We can do long length to diameter ratios, and part of that is, let's say, the ability to continuously evacuate the flutes, but it's also rigidity related, and they're very customizable. Right. So if you want a step drill, no problem. You want to add a countersink, extra diameter, those type of things can be done. Kind of on the minus side is, to get the best possible use from your investment, you're going to regrind them. So you're going to send them to a reconditioning center, have them resharpened, new edge prep applied, new coating.
And every time that's reconditioned, you're going to lose a little bit on your hole diameter as well.
You will. And we'll definitely go into this a little bit more, but just to get it started a little bit, when we flip the modular drills, of course, the big advantage is that you can keep that body, you can pop that tip out, put a new tip in, and go right back to where you were. So we don't have that change around. And inventory is a big thing. So what do you have to have on hand? And definitely we'll kind of visit that a little bit further in the webinar.
A little bit more versatile because we can have different modular tips or different tips that we use for different materials. I think of that. And I also think of, we talked about the overlap, which we had on our previous slide with carbide reels. I know that when we developed the dual lock for milling, and I want to bring in another topic in this webinar because we're here to talk about KenTIP FS, but dual lock, that I've always thought that the great thing about the development of that product was that when we were doing all our development work, we were not developing that tool to go after just the other modular end mills. We were going mostly after solid carbide.
Right.
So we wanted to keep our performance at that same level and not go down, because a lot of times when you go to modular, and just like we talked about, your quality or your performance may step down just a little bit. But when we developed KenTIP FS, it was the research and development that we put into it was to develop something that not only is competitive with other modular systems, but competitive to solid carbide. Yeah,
that's a great point, and that's where definitely we want to get down into those smaller sizes and really need to do that. I saw somebody asked a question in the webinar already. Where was this designed? And Germany, U.S., where? And it was a global team that worked on this tool. So quite a lot of a ton of R&D has gone into this tool, from the body, from the tip, tons of FEA, tons of testing, and just another way to sort of showcase our engineering capabilities.
Yeah, that's the cool thing about Kennametal. We do have global R&D labs and engineers all over the world that contribute a lot to the development of these type of tools.
Mm-hmm.
Cool.
All right. So, yeah, let's jump over to where we talk about the comparing to the old KenTIP a little bit. I just saw a question that came in. Somebody was asking how many changes can you do until the steel body wears out. It definitely is going to depend a little bit on how harsh your drilling conditions are, things like that. But a good average number we usually use is about 20 changes. So we did quite a bit more than that in our internal testing, but that's a good typical number for general use, which is definitely up from the previous KenTIP.
And that kind of leads us into our next topic too, about how it compares to the previous.
It does, absolutely. So body life is a big thing, and that's exactly what we were just talking about there. So what tends to happen is we tend to have issues with modular tools that are based on some sort of, let's say, cam type locking mechanism that we're fatiguing the body as we take it in and out. Of course, drilling forces are causing the insert to move around within that, stressing that area. And so that's where a lot of work went into the new pocket seat that we'll talk about. Also, we've got a whole new steel body along with that. Stainless steel is a really difficult thing to deal with modular drills. We talked a lot last webinar about the difficulties in stainless steel, and so this is something that we address here. And of course, just overall handling and things like that is interesting. So some of the things that we sought to improve on with the original KenTIP was to improve that body life, like we said, work on the ability to drill stainless steel and drill it better, be able to handle longer length to diameter ratios. So we've got stock up to 12 times D now for KenTIP FS. Right. And then to really improve also our insert life. So that's some of the things that we really tried to tackle.
One thing I see on this slide here that I think we need to point out is when we look at the regular KenTIP on the left and we look at the KenTIP FS, we talked about modulars having a continuous carbide on the cutting edge, but the nice thing about KenTIP FS is it's not only continuous carbide along the cutting edge, but the entire drill body, the steel portion of it, is basically covered with carbide.
Yes.
So you can see here easily in these two illustrations that we have, you can see the steel body being exposed on the regular KenTIP, and everything's covered with the new KenTIP FS. And I think that's a big advantage we have with that new design.
It really is. Yep. So let's kind of next talk. We're going to mention briefly here the coolant, then we're going to get into it a little deeper. So that has a lot to do with one of the things that's so cool about this tool is how we provide a single body, but yet multiple coolant options based on how we treat the inserts. And that's going to get really interesting as we get into things like somebody else just asked about stainless and high temp alloys, and we'll talk in a minute about how we target that. So let's go ahead, Danny, and move to the next slide. Yeah, I want to talk about the interface a little bit. So I want to talk about this slide for a minute, and then we're going to go to our close-up cam and look at some 3D models here. So one of the biggest things is that everything related to this interface, all these pocket seat elements are inside the clamping area. So we don't have anything external. It's very well designed. There's not a lot of stress concentrations. There's tons of FEA that was done on this. There are very large contact surfaces. So what's highlighted here as number 2, you can see here, and I'll show that on an insert here in just a second. That's kind of in the axial direction. We have these tapered surfaces that help with the clamping. We have this retention area, and then we have this huge drive block. So what I'm going to do, I'm going to switch cameras for a second. When I do that, don't be surprised. The the screen will go black for a second,
Maybe a
audio
slight
go,
pause, yeah.
and we'll be right back with you on the close-up camera. Okay, great. So let's do a little bit of show and tell here. So I've got some of my 3D printed models, and we're going to start out with kind of taking this guy apart right here. All right, so this is just a twist, lock, and unlock. All right, and what I want to show a little bit is going to be how this tapered surface goes together. Now, we've got, of course, two parts. So we've got the insert itself, all right, and we've got on the other side, this would be the top of the steel body. So one of the surfaces that we talked about that's of course important, let's say, is the bottom surface here, but especially this surface right here. This is kind of your axial drive,
right.
You could almost call it, right? So that's really where you're able to provide your thrust force. You've got these tapered sections in here, okay, which match up with your body to help lock it in place. So it's both tapered in these areas here. And then one of the things that I really want to point out is, you know, what we call the drive block. And I'm going to go to a little bigger 3D model here just to get it to focus a little bit better.
There it goes.
All right. So this area here is what we call the drive block. And if you look at that, you can see, you know, just how wide and how big it is. That is what's providing your torque, your torsion transmission. So this thing is really, really strong in terms of, you know, we have a big surface here to take your axial forces. You know, then we have the big, massive drive blocks to help transmit torque. And then, of course, we've got your kind of cam surfaces that help lock it in, and a bunch of stuff too.
And that large drive block that you're pointing out is not only important on the insert, but it's also important on the drill body, because it also has the mirror of that. That's right. Yep. Yep. So that's, you know, that's one of the things that that we kind of wanted to talk about. While we're here, I'm going to go ahead and kind of introduce this topic. We're going to talk about it a little further as we go along, but just so we don't have to switch cameras as much. One of the points that we're going to make has to do with coolant in a minute. Mm-hmm. So we have a couple different options of, let's say, between inserts that are designed for steel and will be a solid insert, right? We'll talk about why a little bit. And inserts for stainless steel and cast iron, which are actually through coolant inserts. So, and you can kind of see then how those coolant holes would then line up with the coolant holes in the body. Yeah, so we talked a little bit in our last webinar about stainless steel with the SGL drill and how the material's gummy and how it work hardens. So this geometry here that you're showing with the through coolant holes helps out with that as well. It really does, and it helps in a lot of ways. I guess while I have it here, I'm just going to go ahead and show it, and we can kind of refer to it back. So this particular stainless steel geometry is really, really interesting. We've got the through coolant capability. We've got some slides that we'll talk about to show what the intention of that is. But you can also already see and kind of go back and refer to how different this geometry is specifically for stainless steel. So we actually have 4 different cutting edges that match up with 4 different flute sections, so that we can actually create individual chips and treat them differently when we get into. Yeah, we have a video for that too. To show it, but it's, I don't know if you want to show that now or not, but that's a really cool feature, and I think the video is really nice about showing how those chips are developed. Yeah, we can go a little further and come back to that, but I figured while we had the close-up view, we'd show it. I'm going to switch cameras again, so everybody, if you see the screen go black, just wait a few seconds. It will be right back. Okay, I'm back. Okay, so let's flip back over to the presentation for just a second. All right, Annie.
All right, so we talked about kind of the different features of the interface, you know, and biggest thing at the end of the day, what is this thing designed to do? One, it's designed to be very easy for you to use. Simply pop in, pop out with a wrench.
Mm-hmm.
Biggest thing is to be able to really increase how much force it can handle. So between the insert geometries and between the design of this pocket, we can really increase our feed rates with this design. And really the stress in the pocket has been reduced greatly.
And that's been the restriction for modular drills. Is we've talked about that before. With solid carbide, you can feed it, you can be more aggressive, and it's all because of, I kind of think of it this way. You're only as strong as your weakest link, and with modular drilling, that interface, that in connection, is usually where your weakest link is. So the more engineering that we can put into that and to make that connection stronger, the more the better that tool's going to perform.
Yep,
and that's the reason why this tool is
Yep.
able to be fed higher feed rates and compete more with the solid carbide brand.
Mm-hmm. And one thing just to point out real quickly in terms of this idea of a modular tool, so these different inserts that we're showing all go to the same body.
Yes.
And so, you can have that one body, you change materials, you can put in a different insert, and that's not only going to change what geometry you have, it's going to change what grade you have for that material. We'll talk about that. And it's going to change the coolant delivery, which is all pretty neat. So,
I know we want to talk a little bit about the coolant portion of it, but I guess before we do that, I think it may be good for us to go ahead and talk a little bit while we're talking about the connection on how we connect it.
Okay.
How do you exchange these carbide tips on the drills, and what's the correct way?
Okay, great. Yeah, let's talk about that a little bit. Yeah, so again, this is quite an engineered connection.
Mm-hmm.
It does fit extremely tight. Obviously, it has to. So first thing for mounting, we would just recommend that you clean out the pocket. You can just use compressed air. Be a little careful, of course. Ones that you're using all the time, that pocket's going to stay pretty clean. It's pretty well sealed off. You take it, blow it out. If this is a tool that you haven't used in a while and your coolant, let's say, tends to evaporate, get a little bit sticky, you might need to do a little bit extra cleaning. The biggest thing is blow it out, and then just very simply, you're going to set your insert down on top. Okay, so the two pieces kind of fit together. You can twist it a little bit by hand to start it. So in, a little bit by hand. Then you're going to put your wrench on. We've got two little grooves specifically for your wrench.
Right.
And you're just going to turn it. You'll feel it just lock in. And that's good enough. So,
and we show the wrenches here in the screenshot we have here, and I think we have slide that shows the different types of wrenches that we have.
Yeah, we have 3 different wrench types. So the smallest wrench is really cool. It's kind of just for that 6 and 8 millimeter tip range. It actually has a magnet in it, which would definitely help you keep from dropping those little tips. So that's very handy. So you can kind of put the tip in onto the magnet, put it on the top, carefully get it started, turn it to lock. We've got kind of our original style there in the middle that we've had for years, and that will handle your 8 to 17 millimeter range. And then we've got the multi-wrench, which is available for all the way up to the biggest size. It'll handle down to 8 millimeters. So at minimum, if you were to do the whole range, you could do it with 2 wrenches, smallest one on the left and then the multi-wrench. But that's kind of up to you.
Right. So bottom line, it's not that difficult for interchanges.
It's
just
not.
Inspect it, make sure there's no damage been done to it, as it's been sitting around in your shop and stuff, and keep it blown out, keep the debris out.
Right.
And that's pretty much it. I mean, everything else is pretty simple.
Yeah, there's no torque wrench, there's no real special tools or anything like that.
All right, cool. That's awesome. All right, so I think it may be good for us to talk a little bit about the different geometries. I know you've already touched base on it, but maybe we can show the different geometries for steels and cast iron and for stainless steel, and discuss those and what the advantages are with each, and then we can maybe show some of the videos we've got as well.
Yeah, that'd be great, Danny. So yeah, let's go on to the next slide then, and we'll talk about the insert geometry a little bit. So we kind of already mentioned it, that we've got 3 distinct different geometries, and again, it's the grade, it's the geometry, and then a lot of little details that go into that. So the edge prep is going to be a little bit different depending on that material class. There's additional protection chamfers and things like that that come into play as well. But overall, just to kind of keep it simple, again, all three are going to be able to be used in the same body. All three are going to give you a full solid carbide front all the way across, so full flute all the way across, and full peripheral all the way around. You can see a little bit some of the differences in the tip style there when you look at the two. So the kind of top to bottom, if I look at these over here, I'm going to have the HPG insert, so that's for steel. I have the HPL for stainless, and I have the HPC for cast iron. And you can see that listed here down at the bottom. So again, we mentioned it. And one of the things to point out, why do we make such a big deal about this sort of full face insert, is we're able to do this in such a way that the chips are only forming on the carbide. So we have a really nice polished steel body with good effective chip flutes. But in order to make that body last as long as possible, we want the main wear surface to be on the carbide. And so a lot of work has gone into this design to make sure that that happens, of exactly how long does that have to be, how curved does it have to be in order to shape the chips in that way. Yeah, that's one we do have a video for. If you want to show the video for the HPG insert, we can kind of talk through it a little bit. Great to see all the comments from people coming in. And all right, so in this video here, this is a slow motion video. It's done dry just so that you can better see the chips. You're going to see typical drilling chips starting right now. I mean, we've got the chips starting off of the chisel. It's an extruded chip. We talked about it a little bit before, but you're always going to have this long stringy chip in the beginning coming off the chisel. As it starts to work, we're not into the hole yet at this point, so it's not constrained, and that's where these long chips come from. Now we're getting to the point we're now constrained. We've got that chip surrounded, and we're pushing it back onto the flute. That's going to cause it to curl more and break. So now we've got the nice little popcorn type chips that are really forming. But when you look at that, at the end of the day, once we hit that, even in the beginning when we have the long chips, they're going out and away from the body. Right. But once we really get fully engaged into the hole, then we're going to trap those just onto that carbide. And that's nice.
Yeah, I noticed it does that before the carbide gets fully engaged into the material. So that shows that basically all the wear mechanism is done on the carbide itself, like you said. So that's how we're able to get more interchanges with those carbide head on steel bodies, is because we're being so protective of the steel body.
That's right. Yeah. If you want, you could go ahead and cue up the one for the HPL.
Okay.
So somebody just asked a good question. Why isn't there any through coolant on the HPG insert? And it's a great question. So we're going to show how the coolant works for that setup in just a minute. The main reason that there's two reasons really. So one reason is how we want the coolant to come in and attack the chip. It's a little different when we approach steel. It's a little different when we approach stainless. The other thing is that we can make the steel insert a little bit stronger. So, with we take the coolant holes out, we reroute the coolant. We have a stronger setup for steel, a little higher forces as we get into harder steels, and a little bit different chip formation. But when we get into the stainless, the biggest thing is we're just not going to be successful unless we're able to lubricate from two different directions. So yeah, if you want to go ahead and start the next video.
Let's see the chip formation on this.
So this is the HPL. This is the stainless steel insert. So just a few minutes ago, I showed on the close-up view how that flute shape worked and how there's two distinct sets of cutting edges and two distinct flutes. And you can actually see it now. So if you look kind of here in the middle, you'll see that there's chips coming off the gashing or forming and going down that flute. Exactly. So now you've got that extra set coming, and as it goes, deeper in, that will continue. Now, still, they're only going to be forming on those faces, but you can see exactly how that works. So one of the difficulties with stainless steel, is we have to figure out how to direct what's unfortunately a lot of times nasty chips. And this gives a pretty interesting solution because it keeps those two chips from intertwining and causing more problems with chip evacuation.
I'm playing it one more time just so everybody can get another look at those chip formations.
Okay.
I think it's really neat how it starts with the one chip formation and then generates the second one. So you can see the first one now, and right about here you'll see the second chip formation starting.
And for today's webinar, we managed to use a little bit more of these slow motion videos. We hope that'll kind of give you some little bit of insight to what we were trying to do with these different styles.
All right, so I'll go ahead and stop that now. And,
okay.
I think it may be good for us to talk a little bit about the coolant holes, because I know that's already been brought up in a question. So maybe we can talk about
let's go back to the
designs.
Let's go back to the presentation for a minute, and we'll talk through about the coolant holes. So, again, there's just a great picture to kind of demonstrate here. So if you look at the body design, like I said, it's the same thing. So we've got coolant holes coming up through the body, and actually there are 4 coolant exits in every body. Okay, so there's 2 here in the center and 2 in the flutes. Regardless of which insert you choose, the ones in the flutes are open and activated. For materials where we want some extra lubrication and or extra heat management, we go ahead and extend those coolant holes through the insert. Right. So that's the HPL and the HPC. We talked about the steel insert of wanting to make it a little bit more rigid. And so, like we said, that's one of the main reasons that the coolant holes don't come through there.
So it still has coolant, but it
still has coolant, just
insert
from a different direction. And it's still, of course, coming down to the bottom of the hole. So, and if you, let's say we jump to the next slide for a second, we can kind of show a little bit of what we mean. So if we look on the left of the HPG or steel strategy, where we bring it from the flute side. So we're bringing the coolant in on the rake surface. So we're running it down the flute, kind of along the rake surface and behind the chip. And let's say in a freer cutting steel, we're not talking about having something that is very gummy and things like that. We're much more concerned about the heat on the rake side. When we get into stuff like stainless, so for those of you, again, that didn't see the last webinar on SGL, there's a part where we talk about work hardening, plastic deformations. That's kind of cool, that would get into why it's gummier. But also, one of the things that we talked about in that webinar was a little bit about thermal conductivity, how much lower the thermal conductivity is of stainless steel than steel, alloy steel. So we've got to be much more sensitive toward driving the heat out, not transferring that heat directly back into the tool. So we cool it from 2 sides. And the tool life that you're going to pick up there is going to be much better, even though you're giving up a little bit of rigidity. It's a trade-off, but it's a trade-off in the right direction. And that shows that a little bit. And we actually have some more slow motion videos that we can show you to show exactly how this looks. So if you want, Danny, maybe cue up the steel one first for the HPG insert. All right, so you can see we're just getting started here. All right, coolant's full on. One of the biggest things I want kind of everybody to see is exactly where that coolant is hitting. So all of this design work is done to position those coolant hole exits so that it is hitting right there on the cutting edge. It's hitting a little bit before the cutting edge on the rake surface, come up under that chip, and get toward the cutting edge. And that's, that's again a big advantage. And of course, we're putting all the pressure in that direction. So you got to remember, of course, fluid mechanics, right? When we go to the 4, we're going to split it. But here we've got your high pressure going right in behind that chip. And down
when I seen this video for the first time, I thought, well, it looks like there's coolant holes at the end of the insert, because when you see this spray at the very end, it looks like it's coming out holes at the end of the insert. But it's, like you said, it's hitting the cutting edge, and because of the helix of the insert, it's actually deflecting it and makes it looks like there's
it's pretty wild, isn't it? So we could compare this if you want to queue up the one for the HPL and the HPC. We can kind of show how that compares a little bit.
So this one will have coolant holes out the center, or at the end of the insert.
Yeah. So somebody just read my mind and commented how good these clips are. I was just about to ask what people thought of them. So yeah, these are really nice. And so if you look here, this is HPL and HPC. So you can see exactly what it looks like now. So you would have a little bit of pressure drop, of course, on the flute side. But now you're bringing that coolant from 2 directions. And so we talked about, again, like we said, thermal conductivity, the overall gumminess of stainless steel, and how much that really helps. Cast iron, certainly there's some strong benefits too. So we're dealing with a much more abrasive material. We don't have to worry about it in terms of work hardening and things like that, but we can certainly work on lowering the wear, helping to flush the chips out in a different way. If you think about cast iron and how we have to move chips, it's completely different, right? Because we saw those nice, pretty steel chips. We saw kind of the longer, ugly stainless steel chips. We start getting into a cast iron or CGI or ADI, and we start getting a little bit closer to powder. Flushing those chips out is much different. So the more we pump down in there in the bottom, the better it is to get that up and out of the hole.
So I think we need to talk a little bit about the coolant holes in the body itself. We've been talking about the inserts or the replaceable tips with coolant holes and without. So let's talk a little bit about the coolant holes inside the body itself.
All right, and that is something that we did make a big change in, going from the KenTIP or even the KSCM to the KenTIP FS. So you can see here, let's just say the first thing to point out is that we can increase the volume of coolant because we've gone to 2 coolant holes in the body versus 1 down the center. Okay, so immediately we're able to bring a higher volume of coolant. But the next thing that wouldn't be obvious normally, but is really interesting, is the fact that by taking the coolant hole out of the center, we can reduce the core diameter. And well, what does that do for us? I mean, we need that for rigidity, right? But the fact that we don't have that hole there, we can make it a little smaller. We can make those chip flutes much wider, much deeper than they were before. And that's where it gets really helpful as we start to jump into, hey, we can now go 12 times D, things like that. We've got a much better way to get the chips out of the hole because we're simply able to have more flute room. So we have more coolant coming through, almost double the amount that we had before, and a little bit bigger flute.
And a stronger core.
And a stronger core. Yeah. If you go back one slide for just a second, Danny. So we can also just briefly mention, along with that, you talked about it earlier, this is now a fully spiral flute. So before, typically we used a spiral followed by a straight. So again, also to kind of help in deeper holes. These bodies also have very highly polished flutes. So also, again, to help handle the chips, help get the chips up and out of the hole. So just a little point there that we want to point out. So I think let's kind of revisit this idea about reconditioning and kind of how that would change a little bit. I think we've got one more slide for that. Okay, so talking about solid carbide drills. So, like we mentioned earlier, there's definitely advantages to both, right? There's a reason we spend a lot of time engineering both. But one of the things that you're going to have to manage with solid carbide drills is, of course, length changes. So you probably need some presetting or something like that to help with that. You're also going to have a little bit of an issue with, we put back taper into the design of drills. In other words, the diameter is smaller as it goes back down the shank.
Right.
And that's an additional form of clearance. So as we shorten the drill axially, the diameter is going to get a little bit smaller, a little bit smaller, a little bit smaller. A little bit more than what the additional coating is going to make up for.
All right, it's a small amount, but depending on how tight your tolerance is on your hole, it could play a factor.
So if you use a modular drill for the same setup, then you're able to keep the same length, the same diameter. You're not going to worry about reconditioning. You're just going to take that tip out, put a new tip in, and go back to what
recycle instead of reconditioning.
Right. And exactly that. So obviously we offer recycling programs. We certainly encourage people to take advantage of them. And so you just recycle that tip. So it will also change a little bit your inventory and how you handle your inventory. So we had a customer that used a term I like called their loop, where you have the drills that are in the machine, you have the drills that are in your cabinet, you have drills that are out for reconditioning, you have drills that are coming back from reconditioning. And so really you have to look at having enough drills to keep all of those parts of the pipeline full. With something like KenTIP FS, you have your tools that are using, you have your tools that are on your shelf ready to replace, those tips that are ready to replace. So so that could be a situation that they could save you money. So definitely something to look at of how that could help your inventory cost. Cool. All right.
So I think now, Steve, it might be a good time for us to maybe look at some of the questions that we've got coming in and maybe see if we can answer some of those before we sign off for today.
Sure.
So there's one here that says, is reconditioning possible on the KenTIP FS?
Yeah. And the answer for the KenTIP FS, we don't offer reconditioning for KenTIP FS. KSEM, kind of the next size up, is reconditionable. KenTIP FS is more for recycling. And there's just, unfortunately, it's designed so that we have enough room to give you that full interface to the chip, full coverage there, but no more than you need to keep the cost down. Okay, and the minimum amount of carbide. So yeah, so it would just be recycled. Somebody
asked if would the range overlap into KCSM more like the 35 millimeter or more. So what is our size range that we have on KenTIP FS?
Yeah, so right now we go up to that 26 millimeter range. We're always looking at new opportunities and have different projects in the works. So you could see different insert styles coming out in the future in terms of more tips, more shapes. You could see possibly different diameters as well. But what we have currently, launched in the marketplace is the 6-16. Yeah.
And I think to me, what's more interesting is not how large a diameter will go, but how small a diameter will go. I mean, going down to 6 millimeters is impressive, and that's one reason why the modular drill system that we have can be in that solid carbide realm, because usually that's the limiting factor for it.
Right. We had somebody ask the question about the length between KenTIP and KenTIP FS is not the same. Good question. Maybe Danny, just go back to slide 5, if you would. We had both. So just go in here for just a second, because we've got original KenTIP on the left, KenTIP FS on the right. If you look at the original KenTIP, So the main section of the flute and most of the periphery was carbide, but it's backed up with steel over here and steel on the other side. So that was one of the things that we really wanted to change going into the KenTIP FS. So, and along with that, it's just a completely different pocket seat design. So with those two things kind of put together, we end up with a little bit different overall height to that insert. So it is, let's say, the same concept in terms of a modular drill, but they are two different inserts, two different bodies. They're not interchangeable, and yeah, different concept. So let's see if we've got some others. Somebody had asked, do we experiment with other geometries? Yes. One of the things that maybe seeing us talk in some of these webinars, you'll start to get, we're always playing with something.
We have several projects going on.
So we're always trying different geometries, both from a pure grind it and go try it standpoint, FEA, FEM analysis. We showed some of that with the Harvey 1TE before. We're looking at every possible way that we can throw in new geometries that would be a help. So that's, of course, the biggest thing is it's got to be an improvement, right? It's got to be an improvement over something that we already have. But yeah, we will continue to test there. So let's see.
More here. Let's see. There's
there was one question about cross holes. Let's see, let me give you the right slide to go to for just a second, Danny. Go to slide 3 for just a second for me. So one of the things that we want to think about in terms of stuff like that. So the question was, some problems with drilling cross holes. You can kind of see there we have an overlap here down the middle of interrupted cuts. In general, KenTIP FS with that large, we talked about that drive surface and how strong it is, and also how well it locks into the pocket. In general, can move through interrupted cuts just fine. You always, of course, need to test it, because not every uninterrupted cut is the same, of course, right? Depends on maybe cross hole, angle of the cross hole. Yeah. Is it also combined with angled entry or exit, things like that? Those are all things that KenTIP FS can handle. But of course, if you have some issues and you're in the KSEM range, you can also look to try that as well. But I don't know when you tested it. Also, could be that it was under field test, something like that. And we certainly made a lot of improvements as we went through the project. So, but in general, fine for cross holes and interrupted cuts. But always, keep in mind that you do have a couple solutions to pick from if you need it.
Absolutely.
All right, let's see if we have any other questions here.
I think we've touched on. I don't think we've missed any. If we have missed any of them, we definitely can get back with you guys later.
Yeah, we'll go through the chat afterwards.
It's kind of hard to look through all the questions and do the webinar at the same time, but I think we've touched on all of them for now. We'll go back and review. If we've missed any, like I said, we'll respond back in the email and go from there.
Yeah, thank you very much.
For Facebook, if you guys are on Facebook and you have any questions, if they haven't already been addressed by our CAS team, we'll definitely look at those later and get back to you.
Yes, and always feel free to reach out to us through there. Please, we'd love to see some more comments on Facebook and here, just to kind of let us know how we're doing. But please feel free to reach out. Like Danny mentioned, the CAS team is always there to answer questions. You can find the contact information for that on our website. other thing that we would mention, of course, is we do have additional videos on our YouTube channel. So you can check that out. There's some videos, particularly on KenTIP FS. And maybe one last thing, as far as upcoming webinars, we will have another webinar in 2 weeks.
Yep.
And the topic for that will be Novo.
And we'll have a visitor with us. Jeff Martin will be with us. Look forward to seeing him again. It's been a while, and he'll be able to help us out with the Novo presentation.
Yep. So we'll kind of walk through how to get you started with Novo, kind of what it is, how you can get access to it, and that could possibly be a multi-part series. So we'll take a look at that and see how it goes. So, all right. Well, we thank you. We appreciate everybody's time and attention. And again, we hope you all stay safe, and look forward to seeing you in the future. Thank you.
Till next time, guys.
Bye.
See ya.